Now we have to find out which oxides are amphoteric in nature. So first of all we will take the nitric oxide. Nitric oxide symbol is like this and double bond O. This is a symbol of nitric oxide. And this oxide is neutral oxide. Neutral oxide. And why this oxide is neutral? Because the N double bond O is very strong bond. It is very difficult to break this bond, and it is very difficult to hydrolyze this nitric oxide because the bond enthalpy is very high. So it will not react neither with acid or nor with base. That's why it is called a neutral oxide, because of high enthalpy of hydrolyzation. It remains neutral. It don't react with either acid or with the base. Next oxide is boron trioxide. Boron trioxide is acidic in nature. This is acidic in nature. Now why this is acidic in nature? Because there are two reasons for its acidic nature. In boron trioxide, the oxidation state of boron is +3. Here oxidation state is +3. And as per the Lewis concept, anything is acidic if it is accepting electrons. So it's become acid. Anything is basic when it will donate the electron. It is called basic thing. Here H positive is acidic because it has positive charge and it can only accept the electron. That's why it is acidic in nature. And here is a OH negative, that is hydroxide ion. It have electrons, it will give the electron, that's why it is basic in nature. In case of boron, the oxidation state is +3. That means, so it can only accept the electrons. It has not any option. It can only accept the electron. That's why it is acidic in nature. This is one reason, because it is the highest oxidation state. Another reason for its acidity is that boron is 13 group number elements and it is at the top of that groups. It is a p block elements. When we are coming down from the top of the periodic table, in that case metallic character will increases and non-metallic character will decreases. That means in group number 13 boron is a non-metal, and secondly it is in p block elements and it is mostly forming covalent compound. That's why it is acidic in nature, because most of the non-metals oxides are acidic in nature because of their covalent nature. So because of these two reasons, this is boron trioxide is acidic in nature. Now we will see lead oxide, lead dioxide, tin dioxide and tin oxide. These all are amphoteric oxide. These four are amphoteric oxide. Now why these four are amphoteric oxide? Because if you see in group number 14, there are these elements: carbon, silicon, germanium, tin and lead. Okay. In group number 14 there are carbon, silicon, germanium, tin and lead. Now you see this tin and lead at the bottom of this group number 14. And when we are going down, that means here metallic character will increases. From top to down, metallic character will increases. The metallic character will increases, and you know that metals are mostly forming basic oxides. So as per this logic, the oxides of this tin and this lead should be basic. Now when we are moving from left to right in periodic table, the non-metallic character will increase. That means when we are moving from here to here, then group number 14 is coming, and when we are moving left to right, that means non-metallic character is increasing, and this is a p block element. So with this logic it should form, because non-metallic oxide are mostly acidic in nature, so it should form acidic oxide. So it should form basic oxide also, it should form acidic oxide also. By combining these two, acid and basic oxide, it will form amphoteric oxide. and these two will react both with acid and base to form a salt and water. That's why they are forming amphoteric oxide, because they have intermediate nature in between metallic and non-metallic elements. Now next is chromium trioxide and chromium oxide. In chromium trioxide, that is Cr2O3 negative. Cr2O. In chromium trioxide, the oxidation state of chromium is +3. Okay. In chromium oxide, oxidation state of chromium is +2. There is another oxide that is called chromium trioxide. Chromium trioxide, oxidation state is +6. Now you know the Lewis concept, that in Lewis acid is taking electron and base is giving electron. Now you see in this chromium trioxide, the oxidation state is +6. That means it has given up all 6 electrons. Okay. It don't have any electron at its outermost shell. So it can only take the electron just like this H positive ion. So in this case, this is a acidic in nature. Okay. Because this is a highest oxidation state and they only take up the electrons, and electron density will increases in its orbit. That's why it is acidic in nature. Now if you see this chromium oxide, the oxidation state is +2. This is the lowest oxidation state in oxides of the chromium. That means here is lowest oxidation state is +2, and still it has 4 electrons in its orbit. So it can give the electrons. So in this case, this oxide will form basic in nature. This oxide will be basic in nature. And this oxidation state, that is +3 oxidation state, is intermediate between +2 and +6. That's why it should form a amphoteric oxide. So Cr2O3. Next oxide is beryllium oxide and aluminum oxide. And you know, if you see the periodic table, that beryllium and aluminum are form a diagonal relationship. Diagonal relationship means the most of the chemical properties of this beryllium and aluminum are similar. And it is very well known that aluminum oxide is amphoteric oxide. Most of the students will know it, that aluminum oxide is amphoteric oxide, because in many cases its examples are coming. Okay. And why it is amphoteric in nature? Because this is a metal, so metal should form basic oxide, and this come in a periodic table in p block elements, and p block elements are mostly from covalent compounds, and mostly the non-metallic character will increases in p block element from left to right. So it should have both characteristics, that is basic and acidic. That's why aluminum oxide is amphoteric in nature, and it formed diagonal relationship with beryllium oxide. And because of diagonal relationship, their chemical properties are almost similar, and this compound is also amphoteric oxide. So both are logically amphoteric oxide. Now last is zinc oxide. Zinc oxide, it also amphoteric oxide. Okay, because when it will react with the acid, that is HCl, it forms zinc chloride. Okay, and when it will react with the sodium hydroxide, there is a formation of sodium zincate, Na2ZnO2. This is a sodium zincate. It's react both with the acid and base also to give salt and water. So this is also amphoteric oxide, because zinc is a metal, so it should form a basic oxide. And this zinc coming at the boundary between d orbital and p orbital, so that means it should also have non-metallic character, and you know the non-metallic elements are mostly forming acidic. So there is a combination of basic and acidic oxide. That's why it is a amphoteric oxide. So in this way, we have seen which oxides are amphoteric and which oxides are other oxides by giving logical reason. So we now know that zinc oxide, aluminum oxide, beryllium oxide, chromium trioxide, this lead oxide, lead dioxide, tin oxide and tin dioxides are amphoteric in nature. So if you see this option D and C, both are correct option. So friend, this is the solution of this problem. If you like this solution, then subscribe to my channel. And friends, thank you for watching.